All right, welcome back. We're going to go ahead and continue on with our lesson on inequalities. So yesterday, with the last lesson, you looked at problems that were posed to you as a statement as either a true or false. Right, so let's go ahead and say, is 5 greater than or equal to 4? Well, remember our tool last time was to put it on a number line. So we have 4 and 5. Is 5 more than 4? Yeah, it is. So this must be true, right? Because this is the side that represented something that was more. All right. Well, today what we're going to look at is, I'm not just going to ask you to tell me if it's true or false. I want you to tell me all the answers that are greater than 4, or greater than or equal to 4, let's say. All right. Well, let's take a look at a number line. Our number 4, let's put that in the middle, because that's the thing that's kind of the dividing line or the boundary line between true and false. So what about the number 5? Is 5 more than 4? Yeah, it is. Is 6 more than 4? Sure. What about 3? Is 3 more than 4? No, it's not. 4 is more than 3, so I'm not going to put a dot there. So what I'm doing is I'm representing all the solutions with just a point. All right, what about 4.5? Yeah, and if you're starting to get the feel, pretty much it's going to be everything on this side of the 4, right? What about 4? Is 4 greater than or equal to 4? See, the key here is that it can also be equal for it to be true. So this gets the dot as well. So if I have my solution as x is greater than or equal to 4, then I'm going to start at the 4 and shade all the answers that are correct. In this case, it's everything to the right. All right, what about this one? What about x is less than 4? Well, let's take a look. Here's 4 again. I'm looking at numbers that are less than 4. So is 3 less than 4? Yeah. What about 0? 0 less than 4? Zero's gonna, if I space it out better, 0's gonna be way down here. But yeah, 0's less than 4. In fact, all of these numbers are less than 4. What about 4? Is 4 less than 4? No, 4 is equal to 4. So the way I represent this boundary line is I want to put a little dot, open circle here, and that means I'm going to consider all of my answers all the way up to 4. Right, is 5 less than 4? No, that's why nothing gets shaded here. So this kind of, you can think about, these are all the things that make it true, and then on the other side are all the things that are false. Okay, we can actually work backwards. What if I gave you a number line this time? So instead of me giving you this, I'm giving you this. So what if I said, put a 7 here, and I shaded it in and went this way? What do you think that inequality would look like? Well, 7's the important boundary number, and I'm looking for all values that are less than 7. That's where I get the symbol. I want all my values that are less than 7. But because I shaded it in, I want it to be less than or equal to. Right? I'm going to have you guys try these 4 problems. All right, let's see what we got. So I'm looking, our boundary number is 1. I'm looking for numbers that are greater than or equal to 1. The bar goes under it because that's shaded. On this side, I want it less than -1. So it has 2 answers. This one has x is less than -3 or x is greater than or equal to 2. Right? It can't be both, so that's why I'm going to use the word or. This one I want the numbers that are less than or equal to 2 as well as, and x is greater than or equal to, no, just greater than -4. Sometimes we write it x is greater than -4 and x is less than or equal to 2. If you want to get fancy, you could write this all in one, because it's kind of this boundary between -4 and 2. Call these compound inequalities. You can just jam them together. Right? This one you can't, because they're going in opposite directions. You have to separate them. All right. let's move on. So remember I said one of our goals was to solve these types of equations. So let's start out with our process in solving these. So first of all, how many solutions do you think there are? Well, if you go back to this number line and I look at the way I'm shading them, there's actually infinitely many solutions, even in this case, which seems like there's not infinitely many, because remember, I can have the values in between here. So I can always find some kind of a decimal number that's smaller than the one you give me, which is going to make it infinitely many solutions. All right, so let's go ahead and think about how we're going to solve it. Well, we noticed up above the boundary for this number right here is very important. That's the division between where things are either true or false, right? Because on this side it was going to be false. So I want to find that boundary point. So the way you do it is you just solve this as if it were an equation. So I'm going to add 5 to both sides, or x equals 4. That's my boundary point. So if I were to put this on a number line, that's what I would put down first. Now, based on the symbol, is it going to be closed or open? Well, because it's less than or equal to, it's going to be closed. And I'm going to go ahead and mark this right now on my number line. I'm going to put a 4, and I'm going to put a closed dot. All right, finally, I got to figure out which side to shade. So the way I'm going to figure that out is by testing a point, right? Because half of it's true and half of it's false. So we're going to find out which side is which. So I'm going to test the point 0. So I'm just basically picking some point on either side. I choose 0 because what I'm going to do with that point is plug it in and check to see if it's true or false. You see why I chose 0? Less work. So is -5 greater than 3? No, because -5 is back here and 3 is over here. So I know this is false. So when I tested the point 0, it was not true. Therefore, I write false, and this is the side I'm going to shade. So my solution to this problem is x is greater than or equal to 4. Now, some of you are looking for patterns and you're able to see it. That's great. But before we jump to conclusions, let's go ahead and look at a few other problems because I'm going to throw in a tricky one. All right. Here's the next problem I want us to try. If you think you know how to do it, push pause and do it and see if you get the same answer I get. All right. Let's go ahead and find the boundary point. -3 from both sides. So that's my boundary point. I'm going to put that in there first, and then I've got to ask myself, do I include it? In other words, is it open or closed? Well, because there's no equal sign down there, that's going to be open. I'm going to go ahead and do that right now. All right, now I'm going to test the point. So all I have to do is test, I'm going to test 0. The 0 is right here. I'm going to test that right in there. So 3 minus 2 times 0. I'm going to ask myself, is that less than 1? Is 3 less than 1? No, that's false. So I'm going to shade this. So my final answer, and I added in just another blip right here. This is x is greater than 1. Is that what you got when you tried it? Or did you get, that's weird, the symbol changed. You have to think about what's causing that to change, right? So this method will work. Great. But if you learned a trick or if somebody's telling you another way to do it, that's great. But you want to ask yourself, why does that work? Why is that happening? All right. Go ahead and I'm going to have you guys do these 3 problems first. Put your final answer in, and then I'll go over the answers. All right, let's check our answers. 6p minus 2 is greater than 4. Oops, I'm going to make that an equal sign because I want to find my boundary point first. So 6p equals 6, p equals 1. And put the 1 in here. I know that's going to be open. And now I need to test a point. So I'm going to test 0. I always like to test 0. And this is going to go away. So I have 2 times -1 is greater than 4. -2 is greater than 4. That's false. So this is going to get shaded this way. So x, I'll write it down here so it's not too jammed together. X is greater than 1. All right, let's do this one. 9k minus 2 equals 3k plus 22. Minus the 3 to this side. I'm going to put my 4 right in the middle. I know that's going to be an open dot again. Now I'm going to test 0. I'm going to put the 0 in everywhere I see a k. So is -2 less than 22? It sure is. That's true. So this is the side that I shade. We're going to follow the truth. One of the teachers used to say, and I think it helps some students remember that. Right, so x is less than 4. Right? And last one. So that's -3, so don't mess up that negative sign, right? It's a solid. Why is this one closed? Yeah, that's right, because of the less than or equal to. So we're going to go ahead and test 0. Now, careful, 0's on this side, right? 0's more than -3. So when I test 0, got to put it there. So is 1 greater than or equal to 4? No, 1's less than 4. So this is false. I'm going to shape this. This side's true, which means x is less than or equal to -3. All right, in your homework, you have some problems to try like this, and hopefully that made sense. If not, go ahead and watch the video over again, or if you still have questions, please don't hesitate to email your teacher. All right, have a good day.